Using our knowledge on precipitation reactions and ionic equations, we'll just look at a first-hand investigation on precipitation reactions. The aim of today is to investigate the solubility of some salts in water using a precipitation reaction. So that means forming a solid from a soluble solution. What we do is we prepare 1 molar solutions of listed salts, and using their sodium salts for the anions to be tested. So all the anions are going to be different. All the anions will be different, and the sodium, we just use sodium as the cation. And then if we were testing the nitrate salts, we can change the cations. So what we do is we mix a drop of an anion solution and a cation solution on a glass slide or a plastic sheet, and look in the drop to see if a precipitate forms, so some sort of solid like murkiness kind of thing. And then we'll look at the solubility table to check and compare our results to what we expect. And what we really expect is that silver, lead, barium and copper will form precipitates with certain anions. So when we have silver and chloride, what we usually get is a white precipitate, and we know this from previous experiments. And we get a yellow one if we put it with a carbonate. But if we put it with a sulfate, we usually don't get much, and we'll just get a little bit of a white precipitate, or almost none. So we can differentiate between silver chloride, which will be white, and silver carbonate, which will be yellow. For lead, we can't differentiate between any of the precipitates because they'll all be white, but they will precipitate with all 3 of these anions. Barium will have no precipitate with the chloride, but it will precipitate out if we put it with sulfate and if we put it with carbonate. But we can't tell the difference because they form white precipitates. Copper will only form a precipitate with the carbonate, so we won't see any solid if we mix it with a chloride atom or ion or a sulfate ion. So the validity of the experimental results in relation to solubility rules really depends on having sufficiently concentrated electrolyte solutions. So that's why we made up 1 molar solutions, not say 0.1 or less than that. So we need enough of the electrolytes in there to actually form a precipitate. If we don't have enough, then we can't really see what happens, and it will just look like no precipitate has formed. If the solutions are too dilute, so we didn't make it strong enough, they might not form, or we just can't see it because it's just too few of it. The colors of the precipitate should also not be interfered by any ions or other sources, because cross-contamination can affect our results, and we really need to prevent it so we can have accurate results. So we need to make sure we clean all the equipment before use. If we don't clean the equipment before use, we'll bring in ions from other sources which we're not testing at the moment, and it can make us have false positives or false negatives like that. So what we know is that most of the ions are with silver, with lead, barium, copper, will form a precipitate, and sometimes these precipitates form different colors. So with some questions, we can describe a precaution necessary to ensure the validity of this investigation. So what do we need to do to make sure our results are valid or true? We need to guard against contamination of the solutions. If we contaminate the solution, then it's not going to give us accurate results, because what we're looking for is not what we have in the beginning. If we want to look for barium and we have copper in there, then the copper can interfere and give us a false positive. So 1 drop of solution has been placed on the grid. You have to make sure the grid is first of all, clean, and the dropper hasn't touched anything. So make sure when you take the dropper out and put a drop of the solution on there, that when you put it back in, you haven't touched anything, like another grid, or put in the wrong bottle or something like that. So question 12, sodium chloride and sodium sulfate both are white solids and look very similar. Conduct a simple precipitation test to distinguish these 2 salts. So we need to make sure that we can precipitate the ions out. And we know that sodium is soluble in water. Any sodium compounds are soluble in water because sodium is a group 1 compound. a group 1 element, and therefore all group 1 elements are soluble in water. So when we dissolve sodium chloride and sodium sulfate, they won't form a precipitate, they'll just go into aqueous solution. But we know that salts of chloride ions are insoluble with silver, because silver precipitates chloride out. And salts of sulfate ions are insoluble with barium, because we looked at that with the typical results. If we use silver and barium ions, we can then test if the solid here was sodium chloride or sodium sulfate, based on which one we use. But if the concentration of silver ions is high, we can form a precipitate with a sulfate ion. So we need to make sure that we don't have too strong silver solution. So therefore, barium ions is the most appropriate ion to distinguish between them, because barium won't form a precipitate with the chloride like silver can precipitate out sulfate. So we need to make sure we use barium, because it won't give us any false positives. Each solution needs to be prepared in a test tube and a few drops of the barium nitrate solution added. And if a precipitate forms, then we know it's going to be sodium sulfate, not sodium chloride, because barium sulfate will precipitate out. Barium chloride is just an aqueous solution. So what we expect is that different ions can react together to form a precipitate, especially we use silver to see if we have chloride ions present. And like here we said, barium can be used to find if sulfate ions are present. They form white precipitates or yellow precipitates. Copper can also precipitate out to form a blue one, copper carbonate. And we can use these tests to tell us whether or not chloride ions are present, sulfate ions are present, silver is present in the other way, and other metal ions are present or not.